Okay. I think we are. Oh. Now you can leave it open. Hopefully some warm air will come in. If it gets noisy, we'll close it later. So this is the NTP and Tictoc working group meeting. It's a couple of administrative things to get started. First of all, don't forget to sign the blue sheets. Oh, you've already signed it, right? Yeah. Okay. There's supposed to be one on the clipboard, actually. There you go. Second thing, we do have note takers. But I do need a jabber scribe. Is anybody willing to jabber scribe? Kyle, thank you. Okay. So, welcome to the NTP and Tictoc working group meeting. This is the IETF Notewell, which you will have seen before. I guess the hotel staff didn't want me to leave the door open because they just closed it. Oh, well. So anyway, this is the IETF Notewell. If you have any questions, be sure to raise them. And recall that by attending this meeting, you are agreeing to abide by it. Next slide. We have already done the basic administrivia. The agenda for today, so we have our scribes and our note takers. The agenda for today, we're going to go over a number of drafts in the working group status. Then we're going to talk about the status of the network time security work, the Yang data model, some guidelines for defining packet timestamps, which was adopted last time, NTP interleave modes on implementing time. That's the end of the NTP portion of the agenda. And the Tictoc portion of the agenda, we're going to talk about the working group status, and we're going to talk about the Yang data model for 1588 v2. Are there any, is there any agenda bashing, questions, additions, comments? Okay. So go to the next slide. So let's talk a little bit about the current documents that we don't actually have, or that we want to have a little bit of discussion on today, but not necessarily a lot. The first one is the NTP control messages document. This document was published by, update was published by Brian. There were a couple of open issues that we discussed at the last interim meeting, and part of that required getting some feedback from operators on how they are currently using NTP Mode 6. We have not, to my knowledge, gotten this information yet. Do we have anybody that's willing to help Brian get this information? Rob, you'll do it? Okay. Okay. There was a question about the version numbering, and then there was a question about adding additional modes, and the question was whether we needed to add adding additional commands to the mode 6 messages, and whether we needed to do that or not. So are there any questions or comments on this document? Okay. The BCP is in the shepherding write-up stage. There was a couple questions that have been resolved, and so we need to move forward with that. The MAC authentication code for NTP, Anshal's draft, that went through working group last call. There was a, to my knowledge, there was a couple of additional comments that haven't been addressed, including the need for a security consideration section. Did you want to address that at all, Anshal, or do you? At the microphone, if you. I think you're going to have to turn it on because.
I haven't added the security considerations section in the latest draft, but I'll add it in a day or two, probably.
I'm sorry, I just couldn't hear you.
Security considerations section, it'll be added in the next.
It'll be added in the next draft. Okay.
Yes.
So beyond that,
I don't remember any other comments.
I'm trying to remember. One was we need to do security considerations, and then there was the second one was it would be nice to have a discussion of something. It was was that your comment, Tal, I believe?
Tal Mizrahi, one comment I made was it would be nice to discuss whether this could be an extension field rather than the legacy authentication. And I don't know if we went through that discussion already. If we did, sorry?
I think Sharon had some comments about it on the mailing list. We'll resolve the issue. I don't know.
So we resolved it, and the resolution was that it would not be an extension field.
Yes.
It would be a replacement of the.
Yes. Okay. As far as I remember.
Okay, and one more thing was about interoperability. I don't know if that was resolved. There was, I think there should be maybe a small subsection that discusses whether this is interoperable with previous implementations, and if it is, how. If it's not, then just specify it's not.
Okay. Yeah, that was what I recalled from the mailing list. Was there were some additional comments that needed to be addressed. So in addition to in addition to adding a security consideration section, we need to at least figure out those. So other than that, I believe it's past working group last call. We can move on. The client data minimization draft needs to be working group last call. It's ready for working group last call, and that has not been issued, so we need to do that. The ref ID updates has been parked has been temporarily parked, and the NTP correction field. Miroslav was not here, and we're not going to present this draft, but this was actually published, and so I'd like everybody to take a look at it and provide some comments. Any questions about any of the rest of the drafts up here? No. Okay.
Take this. Okay, I'm going to present the network time security draft in behalf of Daniel and Christoph. We had a working group last call. Oh. The last working group last call results in 107 comments. We sorted them in a spreadsheet to get an overview. Currently, about 80% of these comments are resolved, actually. And we already submitted a new version of the draft, the version 10. This version does not contain all of the resolvements of the comments, but there is already a new version of the draft on the GitHub repository, which is going to be the version 11. And in this version, you will find 80% of the comments resolved, so to speak. The most dramatic changes from version 9 to 10 are that we removed everything which is not client-server mode. So the draft does not contain symmetric mode, does not contain control messages, and therefore there is no DTLS tunneling. That was one of the major problems in the last version of the drafts, and we didn't get an agreement, which I personally find quite pity. There have been some technical issues that was indicated by Kyle, Rich, and Martin, and which are more or less resolved. We removed the mentions of PTP because we do not consider broadcast mode. And there has also been adjustments of the requirement language. Okay, next slide, please. There's still some open issues. One of them is that some of the comments wanted to have a ladder diagram to find it easier to understand the draft. So that is going to be prepared. We already have one. We need to translate them in a format that is that works for an RFC. The question for me is, shall we also have a state machine diagram for at least for the client? I personally don't believe that that is necessary. And then there's also an open issue. There are with respect to the cookie format. In the current draft, the cookie format is suggested, and there is some statement that this should be normative. So these are two questions I have for the working group, how we shall proceed at that point. Okay, next slide, please. Yes, next steps. We will work to address all open comments, and we'll try to incorporate them in the next version, and then going for the next working group last call. That's it. Thanks. Are there questions or comments?
Kyle Rose. Is this on? Yeah. Okay. What's the plan for proceeding with modes other than client server? I mean, are we just going to delay that work until after client server mode has been published?
No, in the last interim we discussed to move the symmetric mode and the control mode to a different document.
Okay, we'll work on them in parallel then.
Yeah.
Okay.
Yeah, okay.
Yeah, I missed the end of the interim because I had another meeting.
Okay. So to follow up a little bit on Kyle's question about the remaining modes, this is a fairly significant change, which basically means that this document is only going to address the client server aspects. And I understand the rationale for doing that. As Dieter says, we do believe it is a little bit of a pity. And I am a bit concerned that once we get this done, we're not going to get the rest of the pieces done.
I have something relevant from Daniel. So Daniel Franco says, I expect to put it back into a separate draft, possibly experimental.
Okay.
So that would allow us to gain some deployment experience with it to determine whether or not the jitter issues and whatnot are legitimate.
Right. So anyway, this is the current way forward for this. Time frame, you didn't actually address that, Ditch, or do you and Daniel have a time frame for moving forward?
No, we didn't agreed on the time frame. No. But I suppose we would like, if we could have an interim, we would like to have this fixed for the next interim.
Right. So part of the reason why I'm sort of pushing this is I was really targeting having a hackathon effort around the NTS work at the London IETF. And so it would be, I think that's a real sweet spot. I think it would be very productive if we could do that. It also is in a region where we have the best potential of getting all the people that we need in the room. So I would really like to see us hit that milestone if at all possible. So any other discussion on the security? Wow, this is sort of sucked all of the air out of the working group in the last, and then there's no discussion on it today. So, which I guess is a good thing. So next on the agenda. Okay, so this is going to be a remote presentation. You ready?
Hello.
Hello, go ahead.
Yeah, okay. So, hi, I'm Ankit and I will be presenting the YANG data model for NTP. So, we have done, can you move to next slide? Yeah, so for YANG data model, we have configuration and state variables. Apart from this, we have added most feature of NTP v4 are covered. Can you please move to next slide? Yeah, so as part of this version, we have done some recent changes, which are added different YANG tree for configuring NTP unicast. We have added a separate association node, which is now read-only, aligned with the other NTP nodes. Examples are added for almost all the configuration and operation states. Modification in clock status container is done, and interface container name is updated. Can you please go to next slide? Yeah, so for this one, for unicast, we have actually we have separated unicast and association tree. So as you can see now, unicast node has two key fields, which is address and type, and all the unicast related information will be present over here. The other tree is association tree, which will display all the association NTP has, which is learned dynamically or configured. The configuration can be a unicast or a multicast or broadcast. So these information will be considered over here. So we have added two leaves node, which is local mode and is config flag, just to make sure that what is the mode. If the mode is broadcast, it will display like broadcast, and if it is a configured node, we will receive this Boolean value as true. In case of dynamic, this Boolean value will be false. Can you please go to the next slide? So this is the example for unicast. This is a configuration. The first one is a configuration example. The second one is the get example for displaying the unicast related configuration. Can you please go to the next slide? This is a reference clock configuration example, the first one. So here user is configuring reference clock with statum as 8. The second example is get operation on reference clock node. So that we can see the reference clock current configuration. The third one is global packet statistics, which is to display how many packet NTP has sent, how many it has received, and how many of them are dropped. Can you please go to the next slide? This is the authentication configuration example. So over here, user is doing a authentication configuration with key ID as 10, mode as MD5, and password as ABCD. When user perform a get operation on the same node, we can see all the information as present except the password. The password node will not display what user has configured as the key. Can you please go to the next slide? This is the example for access rule. So here user is configuring access rule as peer and ACL is 2000. This is below is the get example of access node. Can you please go to the next slide? This is the multicast server configuration in which user has configured multicast address as 224.1.1.1 on interface Ethernet 300 with authentication key ID as 10 and port as 1025. Same when user perform the get operation, he will get this information as mentioned over here. Same multicast address as 224.1.1.1 with authentication key 10 and port as 1025. Can you please go to the next slide? This is the multicast client related configuration. So in multicast client, user has to configure the Ethernet and means the interface on which user is going to configure multicast client, and user has to add the address as 224.1.1.1. Below is the get example of multicast client. Can you please go to the next slide? This is the Manycast server configuration. So in Manycast server, user has configured the same IP address 224.1.1.1. In example, we have took the same IP address, and on the interface Ethernet 300. In Manycast, when user do the get operation on Manycast, he can see all these information, same information whatever he has configured. Can you please go to the next slide? Yeah. So in Manycast client, this is the client related configuration where user is configuring the address as 224.1.1 with authentication key ID 10, and during the get operation, the user can see all the data. Please go to the next slide. This is a clock status example, which will tell what is the current NTP status. So it has fields like clock state, which is synchronized or unsynchronized. What is the stratum? What is the reference clock ID? Apart from this, we have added some keynotes of association class so that it can directly refer to the association with which it has synchronized. Can you please go to the next slide? Yeah, this is the display association example. So this will display the current association present for NTP. So for each association, it will display the address, the stratum, a reference source of synchronization, what is the local mode, whether it is a configured session or a dynamically learned session, along with the NTP statistics. For this particular association, how many packets are sent and received. Can you please go to the next slide? Yeah. So now here we will talk about the modification which we have done in clock state container. So over here, you can see that we have added store key for NTP association, these three keys, as we have seen in the previous Yang example. These keys are the association node keys to identify which association is currently used for time synchronization. Can you please go to the next slide? This is the interface container name changes. Earlier, we had the name as interface, then name, which was a bit confusing for the user. So we have referred the IETF interface Yang model, and we have took the naming convention from them. So now our interface node is having interfaces, which has interface and name as the key field. Please go to the next slide. So about the next step, so review comments are welcomed. Some of the review comments which we have displayed in the example are being updated in the draft. So we have already updated it, but we want some more comments to come from working group, so that along with the internal comment and working group comment, we can add it and make a new version release. Please go to the next slide. Yeah, thank you. Any question?
Any questions? Is this working now? Thank you. Okay, so Harlan's joining the queue. Where's my
Okay.
button?
Yeah, thank you, everyone.
That
Go
was
ahead,
fun.
Harlan.
Thank you. I'm assuming you can hear me.
Yes.
Okay. I'm assuming that one of the goals of this is to make sure there's maximum equivalence between the Yang data model interface, the Mode 6 interface, and the SNMP interface.
I don't.
Greg Mirsky, ZT, why it has to be compatible with SNMP?
I'm talking about the information that comes back and the type of operations that can be done.
But you said that compatible. I would say functionally comparable. Compatible is a different thing.
Okay, functionally equivalent then.
Okay.
Oh,
Rob Nagy, Deep Dive Networking. I'm just going to revoice the comparable, and I think even trying to be closely comparable or functionally comparable is asking a little much. I think they have to have value and function. I don't see why they get compared to SNMP, which has been around for way longer. So I guess my question really would be, what are the next steps? When do we stop versioning and say, this works, it's useful today, and move forward? Because we can do this versioning and adding things forever every time we write a new draft. So how do we get this to, this is done for now?
this being the Yang model.
Actually, I think that one thing that we need to understand that we define the base model, and all their extensions can go as argument to the base model. So really don't have to incorporate all existing extensions in a base model. I think that actually we should really identify the base, make a standard, and everything else can just argument, whether it's a standard extension or proprietary extension. That's the beauty of data model.
Right. So to the authors of the document, what your perspective? How hard? What is your perspective on the alignment with SNMP and Mode 6?
Actually, we have not accommodated the Mode 6 in this one. And related to SNMP, as per the netconf standard, that NMDA standard, we have updated our draft. Means as per NMDA standard, we should have a config and the operation state wherever possible in this inside the same container. So if you look to the old version before the working group adoption, it was in different containers. Now we have adjoined almost all the containers. And related to Mode 6, currently we have not added. Means we need suggestion for Mode 6 from working group. If like how to go about Mode 6. If it is really required, we will add Mode 6 related operation also.
Okay, it's unclear to me that it is required. Harlan, do you believe it's required? Are you still there, Harlan? Okay. My interpretation of the answer to Harlan's original question is no, it's not a design objective that they be compatible. And Harlan's coming back into the queue.
Did I make it?
Yeah, you're back.
Thank you. I think great pains were taken to make sure that the SNMP interface could be implemented, and the way that was done was on top of mode 6. The same thing pretty much needs to happen with the Yang data model. We need to make sure that that the protocol has a set of ways to do things, that the process has a set of ways to do things to it, be it query information or alter configuration or do other things. And the ways that would be done would include mode 6, SNMP, and Yang data model. And if we start getting into situations where one of them will do something the others can't, we're making lives really hard on the user.
I think the problem is that
Mhm.
the mode 6 is 10 or 15 years old. SNMP is about 10 years old, the MIB anyway. And what people want to do now with Yang might be different than what they would want to have done previously. So I don't think it's reasonable to hold the Yang module to the standard that we have to keep mode 6.
That may be, but the other part is everybody I've talked to who's doing Yang is doing their own internal implementation of NTP. They're not doing a standalone implementation. And so to end up with a standalone NTP implementation that has a Yang interface to it, that either means somebody's going to have to implement a full Yang engine inside the NTP daemon, which I expect will not go over well, or there needs to be some external process that does Yang interface that has to communicate with the NTP daemon. And right now, the very best way to do that is with mode 6 commands.
Be that as it may, I don't think it's necessarily saying the same thing, that the Yang module has to be tied to what's currently in mode 6.
I'm going for functional equivalence here. I'm trying to get a job done.
Harun, I got your comment. Let me think over it. I will discuss with other authors also, how to implement it for standalone NTP. Maybe we can discuss it offline. And earlier also we had a meeting, if you remember. Me and Drew joined the meeting. Yeah. So let me discuss with Drew once he's back from IETF, and we will have a one-to-one discussion, and we will think like how to implement it for standalone NTP. You are right. Yeah, you are right that if for standalone NTP there will be a problem. So we will think over it and we will find a way. No problem.
Thank you.
All right, any other questions on the Yang module? Okay, Tal, timestamps?
Thanks. My name is Tal Mizrahi. This draft is about packet timestamp formats. It's joint work with Joachim Fabini and Al Morton. Next, please. And this draft is intended for people who design network protocols. And the idea is that there are two main goals to this draft. One is to define a relatively small subset of recommended timestamp formats, a subset of all the timestamp formats that we may be familiar with. And we believe that in most cases, when you're designing a network protocol, one of these recommended formats will fit your requirements. And for these special cases where none of these formats fits your requirements, this draft also specifies guidelines for how to define a new timestamp format. Next, please. So this draft was submitted a few months ago. It was discussed on the mailing list in the last IETF meeting, and it was recently adopted by the working group. The main differences between the previous version and the current version, there are three main differences. Two of them we're going to discuss in the next slides. The third one, we basically split the synchronization aspects from the timestamp format. And the idea is that when you're defining a timestamp format, we don't want to mandate a specific synchronization method. So if you have a specific timestamp format, that doesn't derive how you're going to synchronize the nodes or what level of accuracy is required. So in different systems, you may have different synchronization requirements. The idea is that when you use a certain timestamp format, you will need to define the synchronization aspects, including what is the level of accuracy you expect, how you synchronize the nodes, and so on. Next, please. Another aspect that was added to the current version of this draft based on feedback we received from the working group was more text about things you need to consider before you define a timestamp format or before you choose a timestamp format. So, for example, things you need to consider: the timestamp resolution, the wraparound period, obviously the number of bits you have in your bit budget, and also coexistence with other protocols. For example, if you have NTP running on your system, maybe it makes sense to reuse the same timestamp format as NTP. Next slide, please. Another section that was added to this version of the draft is a timestamp use case section. So this section shows a list of existing network protocols that use timestamps. For each of these protocols, we show which timestamp format is used. So in most cases, one of the recommended timestamp formats is used. In some cases, it's not one of the recommended timestamp formats. In addition to this list and mapping, this section also presents a couple of examples of how a new network protocol specification should use one of the recommended timestamp formats. So you can actually look at one of these examples, and if you're defining a new network protocol, you can kind of reuse that example and do something very similar. Next, please. Okay, so the next steps we're expecting, first of all, there were a few comments which we received on a mailing list that we haven't addressed yet. We plan to address these in the next version of the draft. And another aspect that we started working on and is still work in progress is a control field, an optional control field that can be attached to the timestamp and can specify various types of information related to that timestamp. So for now, we have a very short section that describes more or less what we think the control field should include, but we need to add more text and to have this section be more detailed. So these are the main next steps, and after we do those steps, we expect to suggest to go for a working group last call. Thank you.
Greg Mursky, ZT. I really appreciate this work because it's very helpful, especially as you mentioned, as a reference to other groups who are not that much spend time, so it saves time. Couple things. First, I would like us to agree on a dictionary and differentiate resolution of a timestamp from the accuracy of the clock synchronization, because accuracy clock of synchronization is a property of synchronization protocol, and you mentioned, so you stated that it's outside the scope of this document. The resolution is something that definitely we need to discuss, because as you presented in your table, you have a format that is, for example, PTP truncated. But there is a larger PTP format that has more nanoseconds. Actually, I think it's a picoseconds, right? And frankly, we can discuss and think of whether in some future, near future, we'll need more resolution than we have now with a truncated format. So probably it's worth putting this in the foresight and discussing how we can migrate to the higher resolution of a timestamp. Okay, that's said. And again, I think that what's in the control field for packet timestamp, we can really look at not maybe in the data packet, this information has to be reflected, but impact of a timestamp format onto the control plane in general. So basically that being advertised as capability and negotiated as need to be, either in the control plane or in the data models.
Okay, thank you.
Greg, just a quick question for clarification. You started your comment on resolution saying that we needed to have basically a dictionary.
Yes, differentiate accuracy from the resolution.
Okay.
Because accuracy of a timestamp, I think that's a property or results from the quality of the clock synchronization protocol.
Right, I understood that part of it. What I was wondering was, were you asking for basically a definition of resolution and accuracy, or were you asking for guidance on how to migrate to a higher resolution?
Both. Actually, I want us to use consistent dictionary, and because as Tal stated in the document, they don't really discuss quality of the clock synchronization, and they only discuss the resolution of the timestamp.
I was just trying to clarify that you were actually looking for both the definition and
yes,
the guidance.
both. Yes, you're right, both. Yes, I propose to have it both in the document. So first is to make a clear definition between distinction between accuracy and resolution, and second is I think that it's worth discussing how to migrate to increase resolution of a timestamp.
Okay. Any other questions? Do you have a rough time frame on, I mean, so you have some changes before you want working group last call on this?
Yeah, so we hope the 2 items here will be completed by the next IETF meeting, hopefully. So we hope that by that time we will feel that we're mature for working group adoption. That's the goal.
Okay, thank you.
Thanks.
Anshal, interleave modes.
Hello, everyone. I'm Anjal Malhotra from Boston University. And this work, this draft is jointly written with Miroslav from Red Hat. In this draft, we basically specify, it's an extension to the specification of the network time protocol in RFC 5905. And in this draft, we specify the new modes of NTP called the interleaved modes, which allow an NTP server to provide a more accurate transmit timestamp to its clients or peers. So animation doesn't work.
So now it's not working. It worked in the test.
Well, Ticker is working, but is it a feedback?
Un momento. So, Anshal, were the animations as important in this one, or are they more important in the next one? Like, we can go ahead.
I can.
Your email's on the screen. Do you know a song you want to sing, Anshul, while you're waiting?
Any volunteer?
Okay.
Isn't it late?
Thank you for that, Rob. I think she's ready.
Okay, so this is how typically an NTP time synchronization packet looks like. There are, not all fields are relevant to my talk here. There are 4 kinds of different timestamps here. The one that we are really concerned about here is the transmit timestamp. On a very high level, transmit timestamp is the local time when a packet leaves the system. Okay, so this transmit timestamp can be captured at several different places on the machine. For instance, it can be captured by the NTP daemon using the real time. It can be captured at network drivers. It can be captured at MAC layer of the OSI or at the physical layer. And this is the increasing order of accuracy for the transmit timestamp based on where it is captured on the machine. Now in basic mode, that is the basic mode of NTP that is specified in RFC 5905, this transmit timestamp is supposed to be captured at the NTP daemon. So there is a problem. Questions later?
Yes. Actually, okay, Greg Muskiziti, you said increasing level of accuracy. What is interpretation of accuracy you use? And what's the measure of accuracy? Accurate to what? To real clock? I would say that further you move from NTP daemon, your accuracy decreases.
It is captured at the physical layer. That is the transmit timestamp. All of them are capturing the real time, but where is it captured? When is it captured?
So,
that is
okay,
important.
so that's the fact, and that's counterintuitive, I understand. Because you're running NTP on a daemon, as you move further from daemon, your accuracy decreases.
The timestamp is captured by the NTP daemon, or is it captured at the network drivers, or it is captured at the MAC layer, or it is captured at the
Okay.
physical layer? It's not, yeah.
That's the thing, is that you're doing it in the software,
Yes.
right? So reading in the software can cause you context switching. And the context switching is unpredictable queuing delay. So the fact that when you read this timestamp of the daemon from the kernel, by the time you return to your user space, your delay is unmeasurable.
Yes. And
So in reality, the further you move from the daemon, the less accurate your timestamp reading.
no, wait.
Hi, Rick Salzakama. No, if you think of it as if the daemon is user space and the bottom 3 bullets are actually already in the kernel space, then the closer you move to when the packet actually leaves, closer you move to when the packet actually leaves the host, then it's a more accurate timestamp. It just is.
Again, if you use 1588 and you're updating the clock on the hardware, I agree with you. But if you are running timing in user space, reading the information from the kernel, you're experiencing queuing delay, and that makes your timestamp less accurate.
But if you're reading the time from the kernel and you're already in the kernel, there's no queuing delay. There's no context switch delay.
Okay, let's agree to disagree.
Okay. Well, the transmit timestamp that is captured at the NTP daemon, it includes errors because it is captured before the packet gets its message digest, and all the processing and queuing delays at the network hardware are not included in that timestamp. So what we want to do we want to do better than this. The RFC 5905 only allows the packet to be transmitted that has the transmit timestamp that is captured at the NTP daemon, but we want to do better. So for more accuracy, the transmit timestamp should be captured as close to the wire as possible, ideally at the physical layer.
Okay, hold just one second. Harlan's in the queue. I want to see what he.
Already, I mean, can we do the questions in the end, please?
Do you want to do the questions in the end?
I know,
Okay.
Harlan, you have many questions, but in the end, please.
Okay.
Okay. However, it is difficult to implement the transmit timestamp that is captured at the physical layer in the current packet, because that is mostly available after, right at the moment when the capture is, packet is leaving the system. So the problem is that RFC 5905 doesn't provide any specification for the server, NTP server, to provide this more accurate transmit timestamp to its clients or peers. And this is the gap that this draft tries to fulfill. In this draft, there could be several ways of transmitting this more accurate timestamp to the clients or peers. But in this draft, we talk about the interleaved mode. So what's the interleaved mode of NTP? The interleaved mode allows the NTP packet to contain a transmit timestamp corresponding to the previous packet that was sent to the client or peer. To be more precise, in this draft, we specify a new interleaved client-server mode. We also specify an interleaved symmetric mode with some modifications to the NTP reference implementation. And we specify an interleaved broadcast mode based purely on NTP reference implementation. In this talk, I'll explain our new interleaved client-server mode. So the interleaved client-server mode basically operates similar to the basic client-server mode. And by basic client-server mode, I mean the mode that is specified by RFC 5905, in which the packet contains the transmit timestamp that corresponds to the packet itself. The interleaved client-server mode is similar to basic client-server mode, except that the meaning of origin and transmit timestamp changes. So what happens in basic client-server mode? Well, this is a client, a server, and these are the request and response packets. We have origin timestamp, receive timestamp, and transmit timestamp on these packets. So in basic mode, in the client request, the origin timestamp is 0 or random, and in the response packet from the server, the origin timestamp is equal to the transmit timestamp of the client query. This is how basic client-server mode works. Now notice that on request and response packet, these transmit timestamp correspond to the packets themselves, when the local time on the client and the server when these packets left the system. However, in the interleaved mode, every interleaved mode has to start with a basic mode, because only when the client receives a basic mode response from the server can he query for an interleaved mode. So for every interleaved mode to start, there has to be one basic mode exchange. After the first basic mode exchange, when the client receives the response from the server, the basic response from the server, now in its query for the interleaved mode, the origin timestamp of the client query in the interleaved mode is equal to the received timestamp of the previous response from the server. And in the interleaved response packet from the server, the origin timestamp is equivalent to the received timestamp of the request from the client, as opposed to the transmit timestamp in the basic mode. Now notice in interleaved mode, these transmit timestamps T1 and T3 correspond to that of the previous packet. Right? It's not from the current exchange, they correspond to that of the previous packet. And this T1 and T3 could be more accurate timestamp. Okay, so let's see what it requires for a client and server to behave in interleaved client-server mode. Now the server has to maintain some state for the client, he has to maintain a list of pair of local receive and transmit timestamp for each client. Now, upon getting a request, the server has to compare the origin. On receiving this request, the server has to compare the origin timestamp on the request to the saved pair of receive and transmit timestamp from the client, from his previous request. Now, if these timestamps match, he will reply in the interleaved mode. So two things that the server has to do. One, he has to maintain the list of transmit and receive timestamp for the server, or for each client. And second, upon receiving any request, he has to compare the origin timestamp to the list of to this receive timestamp for the client in order to see if the packet is in basic mode or the interleaved mode. And if it is in the interleaved mode, he replies with this more correct T3 timestamp that he has saved for the client from the previous packet. So this T4, client. For the client to behave in interleaved mode, upon getting a response, he performs all the tests that he usually performs for the basic mode that are specified in RFC 5905. And additionally, for the sanity check, he has to now compare the origin timestamp on the response packet to the receive timestamp as well as the transmit timestamp, in order to make sure that, in order to check if the response is in interleaved mode or basic mode. So the client has to make one additional check in order to identify if the response is in interleaved mode. Now there could be a quirk if somehow in the interleaved mode, the server receives a request in the interleaved mode, but he hasn't saved the receive and transmit timestamp for the client, or has somehow removed it from his memory in order to make some more space. What should the server do? The server should fall back to the basic mode. So now his origin timestamp, the response packet for the interleaved response, should be equivalent to the transmit timestamp of the request packet from the client. So this is his fallback mechanism. He should fall back to the basic mode. Well, this was about interleaved client-server mode. Interleaved symmetric mode, it behaves on the, it also works on the similar principles as the interleaved client-server mode. That is, the response packet in the interleaved mode contains the origin timestamp equivalent to the receive timestamp of the previous packet received from the peer. Now, what is the modification from NTP reference implementation? We want to make sure that if there is a packet loss, and in order to account for unequal polling intervals in symmetric mode, we want to make sure that the peer doesn't compare the origin timestamp to the wrong transmit timestamp of the peer's packet. So that requires some additional restrictions that we specify in our draft. I do not have time to explain it here. But the only thing that's different from the NTP reference implementation is that we account for these two situations, and it requires some additional restrictions on the client, on both the peers. And interleaved broadcast mode that we specify in the draft is based purely on NTP reference implementation. There are no changes there. That will be it. Thank you.
Okay, any questions on this draft?
Hi, Tal Mizrahi. So first question, it's kind of similar to PTP follow-up messages, right? So in PTP, there's a sequence ID, which binds the follow-up message to the corresponding event message with the same sequence number. And that way, when a node receives these two messages, it can use the sequence ID to match the timestamp to the corresponding event message. So I'm not sure I understood in the interleaved mode how you bind the timestamp you received in the current handshake with the correct packets from the previous handshake.
So the client compares the origin timestamp to the receive. So in basic mode, the client compares the origin timestamp of the response to the transmit timestamp, right? If it matches, then that response is in basic mode and it binds the request to the response. However, now if a client wants to support interleave mode, he also compares the origin timestamp to the received timestamp of his request. And if these two matches, the packet is in interleave mode. So then he uses the other mechanism to compute the offset. He takes the timestamps according to.
So for example, if a packet got lost on the way, we won't,
There'll be.
there's no way to get a timestamp for the wrong message, because I'm just asking.
No, because it wouldn't match with the saved received timestamp.
Okay.
I mean, in client server mode, there is just one response, right? So if you don't get a response if a packet is lost, after some time you'll requery and then you'll replace the saved received timestamp and then you can get the message again.
Okay. Another question is, what are the security implications? Because usually if we verify the MAC and we find that it's wrong, we need to drop the packet. But now, if we verify the MAC and we find that it's wrong, we also need to drop packets from the previous handshake and from the next handshake, right? So it's kind of a more complicated process.
If the MAC doesn't
If there's a problem with the MAC, okay, the
Okay.
MAC doesn't.
so you don't accept the packet.
We will need to drop
But
not only the current
compare.
packet, but also probably the previous packet and the next packet. Right?
Well, it depends. If it fails the check of origin timestamp, then you're sure that it's not the right packet. But if it matches if origin timestamp matches the transmit timestamp or receive timestamp, at least the packet is from the right source. There's something wrong with the MAC, right?
Yes.
So either you do not update your state and sit and wait, or if you want to resend the query, then you update your state again, right?
It's just something to consider. I think there should be some text about it in the document. Thanks.
Okay. Harlan, go for it.
Thank you. Earlier there was a discussion about where you get the best time, either in the heart of the kernel or at the edge of the network interface. And the short answer is everybody is right. The problem is there's jitter between the heart of the kernel and the network interfaces and the clocks there. So depending on how you how those clocks can be traced to, depending on the quality of the clocks involved and how well they synchronize, that dramatically affects all of this. The next trick is Dave Mills did huge amounts of work on this and wrote papers, which are on the website, that specifically address interleave mode and specifically address how long it takes to resynchronize if a packet gets dropped. So those issues are very clearly understood. I have not had a chance to look at this new proposal much yet. One of the things that I have discovered here is that the way Dave looks at interleave is fundamentally incompatible with the way my brain looks at it. And it is very difficult for me to read his papers and follow what's going on. And when I do it myself and I explain it to Dave, he doesn't quite follow the way my brain works on it. And let's just say we haven't bothered to pursue that. But this is incredibly intricate stuff, and the net effect of which, to take another half step sideways, if whatever we do passes the basic timestamp checks, and then it has to be covered with a MAC, either the MAC works or it doesn't. And if the packet passes the authentication checks, we process it. If it doesn't, we drop it. One thing I will say about this proposal is I would really love to see the level of analysis that shows how recovery happens from missed timestamps or missed packets and things like that. But yeah, this is clearly a wonderful thing. It should have been in 5905 because interleave mode has been around for a long time and we just sort of forgot to put it in there. And I pulled it out of the current, I disabled it in the reference implementation because there were issues involved with some of the recent security things and I couldn't get them fixed in time. So I just disabled interleave mode. But we're getting ready to add all that stuff back in, and I'm going to be very curious to see how the way we would do it matches up with what Anshul and Miroslav have come up with.
Okay, so there was no question in there, right?
If there was, I didn't write it all down, so I forgot. But it would be really good
Okay.
to. Oh, you're right. There was probably no question. There was some requests for additional documentation and showing how the recovery process works. And I will say that as Anshul went through her discussion, my eyes glazed over because she looks at it differently from the way I look at it, which is different from the way Dave looks at it.
Okay. Krista, did you want to say something? Go ahead.
Yeah, for your first comment and for everybody else's comments, this draft does not really, it's not about how more accurate timestamp should be captured. It's more about how the transmit timestamp of the previous packet can be sent to the peer or client in the following packet. We don't care. I don't care about whether that timestamp is more accurate or less accurate. It just specifies a way on how to send the transmit timestamp of the previous packet to in the next packet.
Right, that's a good point, actually. Christoph,
Go
ahead.
Yes, can you hear me? Okay.
Yes.
So first of all, yeah, that's a very important point that you just made, Anshul. If that's not heavily emphasized in the document already, then you probably should think about doing that. This limitation of scope towards communication of the timestamp. Then I wanted to lead with first of all, from my point of view as a editor and architect for the security stuff, as many headaches as this might cause in how it should actually be handled, obviously it's great because it would fix the problem of crypto delay, like absolutely, for the first packet. So I think this is very important work for that. And then I have an actual question or an actual issue that I wanted to raise. First, let me clarify if I got this right. Am I correct in thinking that with the way it's currently specified, the server has to keep preemptive per client state because the question is an association going to be handled with interleave mode is only resolved or can only ever be resolved affirmatively when the interleave request comes. And the negation is never going to be actually resolved. It's only going to take forever, and if nothing comes, then obviously this wasn't intended to be in interleave mode. So I would suggest that, if I'm correct in that, I would suggest that this be changed in some way, or at least there should be an option for the server. The first thing that came to my mind was just require the client to put something, an extension field, or I don't know, some additional info into the first, so basically the basic request that semantically just says, I'm going to follow up on this with an interleave packet, please keep state. And if that's not there, then the server doesn't have to keep state. Or alternatively, it could even be handled in a way that has info in the first request, the basic request that says, I want this to have basically a follow-up packet. So even without, it could be done in a way that even without a second request, an interleaved request, the communication scheme could be one client request, and then the server says one response, and then the interleave response, and then closes that piece of state. And that would, yeah, that would save the server from having to keep lots of state. And that's the suggestion, and then I guess some kind of a question is in there implicitly, and that's all I had to say. Thanks.
Yes, the server has to keep a preemptive state per client if he wants to support interleave mode at any point.
Sure.
And for every request, he has to make this check for comparing the origin timestamp to the saved received timestamp.
Right.
But the server is already maintaining some state for the client for this kiss of death packet, like for DOS purposes. So this state maintaining another list of transmit receive timestamp is not a big issue. Like, it's not a lot of memory that it takes for the server to save the state. I and Miroslav actually had this discussion that why not indicate it some other way, and he had better explanation of why not doing that way. I'll leave it to him. Maybe we can discuss it on mailing list. But yes, we thought about these issues.
Christoph, it would be really helpful if you could
Post this.
summarize your comments to the mailing list for a discussion with Miroslav. So, all right. Thank you. Harlan, you're going to have to wait just a minute. I didn't mean to allow you to speak.
Well, now I'm scared to talk. This is Rob Nagy from Deep Dive Networking. I just first want to commend you and Miroslav that I think it's beautiful that you took just what was already there and figured out how to make it work. So for all the comments of let's add this field and let's add that field, to me, that destroys what you just did. The simplification of what you just did was perfect. Now, it took me a while to follow it. I do think, and I need to go read the current version of the draft, addressing here are the security things we could see, here are the security things, going back and looking at PTP and other things we've done to see what they had to address and make sure we've got that. But if we can not add a field or a signal or a serial number, that's beautiful work then. That's my comment. But maybe we can address that in a considerations field or something. It sounds like you've already looked at it, but no real question, just to offset the other comments.
Okay. All right. Go ahead.
Oh,
Go ahead, Greg.
yes, Greg Mirsky, ZT. Well, I still would like to bring the follow-up message because to me the question is what the frequency of queries from the client to the server, because effectively what you're doing by moving your real-time of transmit propagation to the client to the next query, you are dependent on this frequency. So the usefulness of your real time decreases as you increase the interval between the queries from the client. Whereas if you have a follow-up message, the value of your real-time propagation is in control of the server.
I'm not sure if I understand your question. So are you saying that the server should not wait for the second query and just
Yeah,
send...
that's yeah, because that's the idea that PTP has in follow-up message. That actually, again, I can do reference to another RFC that we have in MPLS. It's propagation or support propagation of PTP over MPLS network, whereas we realize that generating consistent, we don't use the term accurate, we're using consistent timestamp close to the hardware may be challenging. So the using follow-up message is another technique. But we are suggesting to generate this follow-up message as soon as possible because that not only decreases the state that you need to hold, but it really makes it useful, because if you delay this real-time propagation, correcting your clock, you're delaying the correction of your clock. Because think of why you're doing it. You want to use this consistent timestamp to do clock correction. Okay, if you are dependent on interval between client queries.
So, Greg, just listening to this, I was wondering if you could possibly summarize this to the mailing list. I think it's an easier conversation to have when you can read and think about the process.
I agree. Okay.
Thank you very much.
I would just want to say that I think latency is not an issue the way NTP handles timestamps. It's just, it should be, the delay should just be symmetrical. I mean, it doesn't really affect the accuracy of what time you'll get.
Okay.
Even if it's after 10
okay.
years, I don't care. I get the response after 10 years. I'll take those 10 years into account while computing my offset.
Okay, your packets will experience different delay traversing the network. And that changes. You don't control it. So that's why, for example, PTP introduces transparent clock, but that's outside the scope of this discussion.
All right, Harlan, quickly.
Okay. First, interleave mode has traditionally been considered to be most useful in symmetric modes, not so much in client-server mode. It would be interesting to get some real data as to how useful interleave mode is in client-server. The concern about follow-up messages with NTP is it doubles the workload and traffic. And from what I believe I've read out of Dave's papers, because I asked him about this before, he said it's just not worth it. There, in all of his research and testing, there just hasn't been any noticeable benefit to doubling the network traffic using a follow-up message like that. But yeah, it'll be good to chat more about this on the mailing list, and Dave would probably be happy to weigh in on it.
Okay, thank you. Just to sort of wrap this up, I do want to thank Anchal and Miroslav. This is a draft we've been wanting for a long time because the basic functionality has been out there. The one thing that I would encourage us to focus on is getting the very basics documented and get that done. And then we can start making it fancier and add additional options. I don't think this is a case where lots of different options is necessarily a good idea. So, last chance. Okay, so we're going to move on to the next agenda item. Anchal, who is probably tired of standing here at this point.
I'm just zombied. So if I say something about the previous draft in this one, pardon me. Okay. Is it working? Okay, so again, I'm Anshul Malhotra. I have to say this from Boston University. And this work, this draft is jointly done with Martin Huffman from Open Net Labs and Willem Torup from NL Net Labs, both of who are present here. And in this draft, we basically provide some guidance to the implementers of applications on how to implement time that use on how to implement time in applications that use time. Okay. So what's the motivation for this draft? Well, we all know, we are an NTP working group, we all know time is important. And without hesitation, we can say that the functionality and security guarantees claimed by many applications running on our systems and in the internet hinges on some notion of time. Now, the implementers of these applications have to choose from multiple time values that are available on our systems. However, currently, these applications and the implementers who implement these applications that use time seem oblivious to the implications of choosing one or the other kind of time values that are available on our system for implementations. And this obliviousness can be attributed to the lack of understanding of different unique specific properties of different kinds of time values that are available on the systems, and also the availability and compatibility of these time values on different kinds of operating systems. So this is what we try to address in this draft. So in this draft, we basically define and describe properties of various time values that are available on modern operating systems. We discussed trade-offs of using one over the other based on application-specific requirements. And all of this provide guidance to the implementers of these applications to make an informed choice. So for the outline of this talk, I'll talk about different kinds of clocks that are available on our systems. I'll define and describe them. Then I'll explain the subtle differences between them. Then I'll explain how different applications express time. That is, it could be timestamps and time spans, and I'll explain the differences between them. Then I'll talk about how these times are handled in current software implementations and why is it bad. And then we offer some alternative approaches on implementing time. So different clocks. Unfortunately, we do not have any standard terminology or definitions for different kinds of clocks available on different systems. So for the purpose of this document, we come up with some terminology. So the first is the wall time. As the name suggests, we naively assume this is the time that the clocks on our wall should show. It is an agreed upon ideal time. This time is, it's an ideal time. It's not available to, it's basically, you can think about it as most applications use UTC time as the wall time. And the UTC time is computed by averaging several high precision timekeeping machines, mostly atomic clocks. So wall time it's an idealized notion of time that everyone craves for, but nobody has access to this time. Every digital system has its own perception of time, so the system provides different kinds of times with its own imperfections that are not as perfect as wall time. So the first kind of time is the raw time. You can think about it as unadjusted or unmodified system time. This kind of time is measured by computing the cycles of the oscillator of a system, so its accuracy depends upon the system's, the quality of system's oscillator. This time is purely a subjective notion of time for the system, and no real value can be actually attached to any of its value. It just represents a passage of time. Another kind of time is adjusted raw time. So this is the raw time which has been fixed for clock drift. Raw time is completely unmodified. Adjusted raw time is the time that you get after adjusting this raw time for clock drift, and this could be externally adjusted by network time protocols, or it could be manually set, as opposed to raw time. Both of these times are monotonic, by the way. And then we have another kind of time that is called real time. It's adjusted raw time, which is to attach some kind of value to time. Adjusted raw time, which is shifted to match wall time, so that we can actually use it to compare with the wall time. So these are the four kinds of times that may or may not be provided by modern operating systems. What are their differences from wall time? So these are the three kinds of time: raw time, adjusted raw time, and real time that I talked about. So raw time and adjusted raw time only represent difference in time between 2 points, whereas real time defines an absolute time value which can be compared to the wall time. Okay, raw time and adjusted raw time are monotonically increasing, whereas real time can jump in either direction. Raw time is not adjusted for clock drifts. However, adjusted raw time and real time are adjustable. They could be adjusted manually and or through network time protocols. Next, I'll explain how different applications use time, in what forms. Applications can use time in form of time spans or timestamps. So what is a time span? A timestamp span represents desired length of time. For example, timeout values on protocols or time to live values. It is usually expressed in terms of length of time. It doesn't have an absolute timestamp. The timestamps, on the other hand, represent a well-defined point in wall time. For instance, the validity of objects that specify from and to the inception as well as the expiration time of an object. For instance, this signature has an inception date, that is 2017 November 29 is its inception date, which is an absolute point in wall time, and so is the expiration date, that is 2017 November 10. Or I said the other way around, yeah. So this is the difference. So basically the time span is a difference between 2 points in time, and timestamps are actually a fixed point in wall time. These are the 2 ways how different applications use time to provide the functionality and security. Can I get the questions after?
Yeah, sure. I can hold it.
Thanks. So how do software implementations deal with these time spans and timestamps? Well, currently, most of the software have a common approach towards handling timestamps and time spans. That is, the time spans are translated to timestamps by adding an offset. To the current real time, we add an offset equivalent to the time span to mark the end of the validity of some object that is that has this time span. And then this timestamp is compared against the current system time to see if it's valid. Now notice that this current system time is updated by network time protocols. So why is this approach bad? Why is this approach bad? Well, using real time is bad because the real time is updated by network time protocols, and it can real time can be set or overwritten manually. It is adjustable. It is subject to adjustments by network time protocols, and these protocols are not very robust. We have shown several. We have talked about it in this session as well. Many recent works show that there can be off-path time shifting and denial of service attacks on these protocols, which can be leveraged to attack various applications that are relying on the time provided by these protocols. So it's a bad idea to use real time. But notice that in case of timestamps, they are always based on wall time. We do not have any option other than using real time. However, that's not the case with time spans. So we have better approaches to implement time spans. So what are the alternative implementation approaches for time spans? First, we should not use real time because for time spans, we have other options. What are the other options? As I talked, raw time. It shows you the passage of time. It is unmodifiable by external means, by network time protocols. It is unaffected by network time protocols and their vulnerabilities. It does have issues with clock drift. So the applications that cannot tolerate clock drifts, they have another option of falling back to adjusted raw time if it's provided by the system, and the applications cannot afford to tolerate the clock drift that is not accounted for in the raw time. It is accounted for in the adjusted raw time. The adjusted raw time, however, is affected by the network. It is adjustable by network time protocols, but at least it is monotonic. It cannot make large jumps. It is adjusted to match the rate of passage of wall time gradually, unlike real time, which can make large shifts forward or backward. So it's at least a better option than real time. So in the end, I would just say that the applications that can tolerate clock drift to a certain amount can use raw time. Otherwise, they can fall back to adjusted raw time. These are our recommendations. Way forward for the draft. Thank you.
Go ahead, Greg.
Yes. Hi, Greg Mirsky, ZT. I think that I questioned your definition of timestamp as it's really tied to wall clock. Because you can have a timestamp of any clock source. the usefulness, yes, I agree. It depends because, for example, if you're doing a unidirectional timestamp comparison without clock synchronization, it's not useful. But if you're doing a round trip timestamp comparison, so then you are comparing timestamp taking on the same node without consideration of one-way time, then you can use not necessarily the wall time. You can use adjusted raw time because you don't need the clock synchronization. So the timestamp is any reading of the clock. No, it's wall time. The wall time is ideal time. As by definition, if we look back in a previous presentation, the wall time is ideal time. And timestamp, it's not necessarily close to ideal time. Your clock can be unsynchronized and still your timestamp will be useful if you're doing round trip delay. Okay, so that's
Okay.
so basically it's just matter of dictionary.
All right. Wilhelm.
So Willem Torop, NLNet Labs. I'm one of the authors, and I think I can clarify that what we mean by timestamps is a point in time expressed in wall time, like the signature, inception, and expiration on the
No, again, that's why it's important to agree on the dictionary.
Yes.
Okay, so because again, I used to understand that timestamp is any reading of the clock. The clock can be synchronized and unsynchronized. It's still a timestamp. Okay, the wall time here, you set the context as its ideal synchronized time across the system.
Yeah.
Okay, but it's not the only type of timestamp you can have. You
So-
can have
so-
a timestamp of unsynchronized clock
So-
and
so we
still
need-
be useful.
Right. So we need to normalize the terminology is what you're
Yes,
saying.
I think
And
that's
I
how
think
I
that
suggest.
that's a fair point. Harlan, and while Harlan is coming to the queue and before he speaks, we're going to cut this off in about 10 minutes or less because we do have a couple other things we need to do.
Okay.
Go ahead, Harlan.
I just wanted to say I think it's, I'll just say it's unfair to say that some of the issues you're bringing up with NTP and laying them there, whenever NTP stops the clock, it writes records in the system accounting log. So if you're trying to get a time span that way, it's up to you to go ahead and look through the accounting records to see if any time steps happen so you can account for that. This is all stuff that gets also covered in absolute versus and difference clocks. So there's a whole lot more going on here and the surface is being scratched, and the same would be true if you were disciplining your clock with PTP or anything else. If you don't have the appropriate interfaces to do difference clocks and you use timestamps to try and calculate a time span, you're gonna have problems. It gets a lot worse with leap smearing and some other issues as well. So I'll just leave it at that right now.
Christoph is next, right?
No,
Okay.
I'll hold it.
All right. So Harlan, I'm booting you, and Christoph, you're in the queue. Go ahead.
Yeah. Again, I want to lead with, I think this is incredibly important that this kind of work gets done on this foundational work. Forgive my ignorance. What's the corresponding document? I might have missed that at the beginning of the presentation.
What?
What's the
Oh,
corresponding document? I haven't found it on the mailing list. I didn't catch it.
It's in the agenda. If you look on the agenda,
Okay.
there's a link to it.
Okay, that's good.
And
And
On implementing time.
okay, thanks.
it's on.
And
It's called On Implementing Time. Maybe if you search for it, or it's on agenda as well.
yeah, I will. And the one thing I wanted to actually talk about was the terminology. When you use monotonic, it seems to suggest you mean both monotonic and then also some notion of continuous, because jumps in the monotonic direction are also implied that that's not happening when it's monotonic. And I would suggest to clean that up, and we can discuss this on the mailing list.
Okay, let's discuss it. I think terminology is going to be really tough in this one, and I think it's something
Yes.
we need to
Yeah,
discuss on the mailing list. Go ahead, Greg.
Yes, Greg Merskiziti. A quick question to authors is that you reference only to NTP as a source of clock synchronization. Have you considered a scenario, or do you see that it will be the same if you have a PTP clock synchronization? Just a question.
Right.
It could be any source, but the point is it's adjustable by external sources, which could be vulnerable, or it depends on their correctness and all sorts of issues. It could be PTP, it could be NTP, SNTP, doesn't matter. Yeah.
Go ahead, Hal.
Tom Mizrahi. I would like to actually expand on Greg's comment. One of the things I was missing is the scope of the draft and the target audience. Because when I started reading the draft, I had a lot of hopes. And then when I continued reading, I saw that it was a bit different than what I thought. For example, as a chip vendor, I'm not sure it's exactly the context that I would be interested in, which is okay. I mean, if you, in the abstract, you explain exactly this is the scope of the document, this is the target audience, we're going to focus on NTP, on implementations of NTP, that would be great. If you think the scope is different, then again, it needs to be explained because it's very important to define the scope. Also, another comment is that I think this the intended status should be informational.
We plan to change it to BCP probably.
BCP would be a lot more difficult.
But
Yeah.
it's
No,
no.
it's
Okay.
not going to fly.
But
as
it's not
BCP.
definitely standard struct, but it was just a mistake while uploading. So we are yet to decide the.
Oh, yeah. I think informational would be the right path. for
Actually,
this.
I can really a little bit expand on what I thought. If you consider covering scenario when you have data plane using PTP clock synchronization and control plane using NTP clock synchronization, that will be interesting too.
So just two high-level observations. One, I think the thing about scope is very important. I think you referenced in particular POSIX, some POSIX, or maybe it was yesterday
Yeah,
that
it
you.
was yesterday.
I don't
It's in
remember
the
which presentation. They're
The
all
document has more details. So
right. So I think looking at calling out interfaces, standardized interfaces that you can suggest that people use seems to be the direction you're going, which seems to make a lot of sense. I think we want to be careful not to target, various hardware interfaces that are specific to, this chip line or that chip line. It needs to be abstracted probably at the OS level if you're talking about applications. I'm wording this badly, but there's that. And then the second thing is I think we need to be very careful about suggesting too much that people need to step away from time that actually has some sense of meaning. And I think this is a conversation we can have on the mailing list, but there are issues, there are downsides to this approach, or to approaches that break the connectivity between real, I don't want to use the term wall time because we've already said that wall time is not a good necessarily the right term, but I think we need to be clear in the consideration section here where this might not necessarily be the best idea. Go ahead.
Ethan Grossman, Dolby Laboratories. Building on what you just said, I felt like one of the things that wasn't immediately clear to me was to what degree are you putting forth the right way and wrong way to do it in terms of the properties of the protocols themselves and as things operate as they're intended to, as opposed to in the presence of security threats. In other words, it seemed like there was kind of a mix in my perception of it between why it's a good idea to do this because the arithmetic doesn't work out versus why is it a good idea to do or not do this because it's a security issue and that it's subject to, to being attacked.
All right. Thank you, Angel. Good work.
Great, thanks.
All right. The thing that just occurs to me is we didn't actually discuss next steps for this document. I'm assuming we're going to rev it once based on the discussion. Are you? Let me rephrase this. You're interested in pursuing this document? I assume. Okay. And can we have an update to it before we do a working group call for adoption? Is that acceptable? Have you gotten enough feedback now to do it, to rev it as an individual submission?
Yes, I think, but if people can actually summarize their comments on the mailing list, it will be easier to address all of them.
I completely agree. I
Yeah.
think we need to have a discussion on the mailing list. And then that discussion would result in another individual submission. And at that point, we'll talk about doing a working group call for adoption. I think having the guidance on implementing time draft along with the guidance on defining or choosing timestamps, I think those are two complementary pieces of work that it would be good to have. So thank you to both sets of people that are working on them. So, all right. So I think this brings us to the Tictoc portion of the agenda. We can move pretty quickly through this. The enterprise profile has gone through working group last call. We have identified one error in the document, and Doug is going to post an update. He was going to do it as soon as sometime this week. So at that point, that document will be going forward. At this point, it's not really a technical change. It's there was a couple digits left off a hex field. So the profile ID had a error in it, but it's not really it's a technical change because it was a mistake, but not a technical change because we're changing what was intended. So last item on the agenda is the Yang data model for 1588 v2.
Well, good afternoon. This is Yuan Long from Huawei. Next slide, please. Last month, we have a last call for the Tictoc document, and we received quite a lot of good suggestions and also comments from work groups such as Tictoc, NetMod, and also the IEEE 1588 experts. And all these comments and suggestions are considered carefully. All the resolutions in consensus are incorporated in the new revision of this document. I think we have quite a lot of editorial changes introduced for this revision, such as the groupings are dropped, and all these codes are moved to the containers respectively. But this is just editorial one, no technical changes. For the module trees, it also has gone through quite a lot of changes. The next slide, please. Please, the next. Oh, thank you. Just as you can see from the tree diagram, we changed the module name, so it's simplified. Also, the scope will be widened. We will maybe later on, we can augment with optional parameters, just as we discussed in the mailing list. But for this revision, we will not consider to adopt any optional parameters. And we also added a root node for PTP. So all these member attributes can belong to a single tree and a single root node. And then we decide to remove redundancies, such as remove the port identity, and we use reuse the clock identity in the default dataset. Again, we use the port number, but we add the type is unsigned int 16, so it's real instance now. For the transparent clock, we also use the same port number unsigned int 16, so it's and we remove the port identity and all the redundant port number or is removed. And then we move the clock identity upwards, so it's inserted in the parent. That's all the changes in the hierarchy of this YARN module. Next, please. After this last call period, and also after the publication of the new revision, we received some more comments. Most of them are editorial one and explanatory. So we will add it in the next revision. For myself, I found some something need to change it in the INA consideration sections. We also spend some time in discussing the introduction text, but after several rounds of discussion, we decided that there's no dramatic changes needed. Some people thought it's useful for the new beginners who are not familiar with PTP or YARN stuff. That such materials still regarded helpful. So finally, I'd like to ask for the work group whether we need another work group's last call or send this document to the IESG for final decision.
So there is one remaining issue that I'd like that we talked about.
Yeah.
So I think if we can get that issue resolved, I don't think we necessarily need another working group last call.
Yeah, we sent an email to Alex for his more feedback, but we didn't receive any opinion yet.
Okay.
I would like to send out another email to the whole working group. Consider all the advantages or disadvantages around whether we need to use the instance number or use the instance name.
Right.
So we can have a consensus in the work group.
Right. So if you could summarize that, send it to the mailing list. I think it's the only remaining open issue that we have.
Good.
So, and then I don't see any reason why we can't move it forward. Go ahead. I guess I should ask.
Suresh Krishnan. So the question I had is like, has this been reviewed by somebody with like YARN expertise? Because I looked at it and there's like some things that didn't look right to me. I'm not a YARN expert, right? So I would really think something going through like a YARN doctors or something would be like a good idea. So if you want something like that, Karen, just like shoot off a note and I'll figure out how to get a review for you before it leaves the working group. Or I can do that after I get it on my plate. That's okay too. But
right. It has had some management area review. I don't know that it hasn't had an official YARN doctors review, but the comments in particular that we're talking about is from Alex, who participates in the NetMod working group.
Okay.
And so I mean, we can go ahead and start.
Yeah, so
the
just
YARN
shoot it off to
doctor
me. So
review.
whenever you're ready, just push the public button and then I'll take it from there.
Yeah.
Push the public button.
Public, like publication request.
Oh, the
as
public.
well.
Oh, okay. I was trying to figure out what the public button was.
Yeah, so whenever you're ready, so just like ship it off to me, I'll take care of it.
Okay.
Is there any other documents you anticipate to come to me like in the next month or so before?
Yeah, there's one
Okay.
BCP.
Okay, thanks.
Maybe I can add some more comments.
Go ahead.
Actually, we sent out this document, the fifth revision, to the net model one group, and I believe one does assignment to the young doctor, but we didn't receive any comments from the young doctors. But other experts, such as Martin and other experts, have expressed their opinions on the main list. So
right, we have worked hard to get feedback from the management community. We just haven't done the official request a Yang doctor review yet, which we're going to have to do. So, but I hopefully we've addressed most of that, so it should be good. All right.
good, thank you.
All right. Thank you. There was one other topic that I thought we had on the agenda, and I just realized that we did not actually have on the agenda. It should have been back up under working group NTP working group status. I just want to point out that at the last virtual interim, we had a discussion about the extension field issue. We asked the authors to go off and see if they could come to some resolution amongst themselves. This is this has not happened yet, and so we will be putting together some formal consensus calls on this topic for the working group mailing list, because I feel that we need to decide whether we're going to make any changes to the way extension fields are handled prior to actually publishing more documents that have extension fields in them. So, and with that, Harlan.
Thank you. Tal and Danny and I got together, I think, twice since then. And it's not clear to me how far apart Hal and I are. Every time I... What?
Well, I was just going to say that I think that there is a difference of opinion that you all have not been able to resolve, and it doesn't necessarily matter who that difference of opinion is with.
Okay.
I don't see a resolution to that.
If that's the case, what I strongly recommend, and what I told to Dieter last week, was that if this is something you care about, I recommend you read the documents, that anybody who cares about it, read the documents, decide what makes sense, and ask any questions they have, and then we go from there, as opposed to watching, me and Danny go at it or something like that.
That's actually what I thought I just indicated.
Okay.
I've seen a couple summaries of the two positions. I want to review these summaries and determine if I feel personally that there's enough information in there for people to discuss. But at some point we need to make a decision and go forward.
Yeah.
And so, and the IETF process to do that is to do a formal consensus call, and so that's what we will be doing. And I'm looking for you and Tal and Danny to help me be sure that the issue is clearly and concisely stated. All right?
Sounds good.
All right. So with that, is there any other business? No? Thank you all very much. Thank you to everybody who did lots of work this time. And, we will look, I see Greg getting, no, you can go ahead and get in any other business. Oh, okay. So the next thing I was going to say is we will plan on a virtual interim meeting probably sometime in mid-December. And at that meeting, I would really like to be ready to to move the NTS document forward so that we can plan. I really think we, as a working group, we need to focus on that. Wouldn't it be great to have a hackathon in March? And I think getting a couple of different implementations of the NTS stuff together and doing some testing and development would be fabulous. So let's really shoot for that. All right, anything else? Thank you all. Have a lovely day. With 5 minutes to spare, we are concluded.
Thank you very much. Not necessarily becomes more accurate. You think you're baiting me? You're baiting me? No, thank you. I would like to, but yeah, I think that's